Hey, welcome back. Today we will discuss what is an update somehow of the idea I proposed about the forced oscillation theory correction. So let's dive into the topic. So forced oscillation revolution, wrong instant equation of motion. The mistake occurs at the very beginning. Disclaimer somehow. Hey there, as I was thinking again on my position about the current theory, about the forced oscillation theory, and triple checking the mathematical physical steps, I suddenly saw how to tell the same thing I told you at the end of the original video or presentation on the subject, just in a simpler and more concise and effective way, and above all in a visual way. So here I am again on the same topic. As always, English isn't my native language, so advices to improve are welcomed. So this is the summary. A quick recap, starting the system, first instant versus regime, equation of motion correction, final recap and conclusion. So quick recap. If you are following me, you may already know that I proposed this correction about the equation of motion of 1 degree of freedom mechanical system. That is to say, going from this equation to this one. The point I came to is that the first thrust of driving force works in resonance, and that instant is a singularity. All the other ones are in quasi-static area, or however complying the correct behavior. So in this video presentation, I'll show you that the error is made at the very beginning of the forced oscillation theory. So starting the system, let's examine then the spring mass damper system schematization. This is the schematization. We are starting the system from rest, whether the force is maximum at the first instant, that is to say force modeled as cosine, or 0 and increasing with time, that is to say model as a sine. The force is acting on the system because of the forcing one, the driving one. Thanks to the driving force as motion primary cause, have diverses as in the representation on the left, that is to say the usual free body schematization is this one, where all the forces except for the driving one points to the left, and the driving one is pointing towards the right. In such configuration, the usual given equation of motion is this one, that becomes the usual one, but that's not true. Moreover, even before exposing the error I'm talking in this video, I mean there's another error. In fact, we have to consider the signs that the usual symbolic set substitutions generate. Velocity is a negative sign, and acceleration is a negative cosine. This is the velocity, which is in the end a negative sign, so that the final expression, when we are dealing with the final physical terms that rule the equation of motion, is this one. Because with the substitution you end up with a function in time that describes the equation of motion correctly. And those signs become those ones. So maybe problems would have arisen earlier. But anyhow, let's go to the point of this video. The initial instant, the first thrust of the driving force, is the only one that has positive displacement and positive or equiversed driving force, and that is the only one to have this property. From the second thrust, and for all the other ones until we go beyond resonance, driving force and displacement are always opposite. Yet the equation is written for the singularity instant and not for the regime ones. So first instant versus regime. What happens between first thrust and second one is represented below. This is the first thrust, this is the second thrust. look at the displacement. In the first thrust, displacement starts from 0. In the second thrust, displacement starts from the maximum positive displacement. The force in the first instant are equiverse, force and displacement. In the second thrust, they are opposite one to each other. The third thrust is instead, this is the schematization of the first thrust. This is the third thrust. As you can see, in the first one, displacement is 0, and there is the balance point. And the third thrust, displacement is the maximum negative displacement. And the forces and displacement in the first thrust are equiversed or equal in the same direction, point in the same direction. And in the third thrust, they are opposite. Force and displacement are opposite one to each other. So the equation of motion correction. Hence, for such configuration, I mean the third thrust, that I repeat is regime 1, not the peculiar starting one, equation of motion is, that's the schematization, the equation of motion is that one, that leads to the usual equation of motion currently used, but we have used a negative symbolic set, that is to say this one, because we are starting from the negative maximum range of motion. If we now substitute the set into the equation of motion, we obtain, this is the equation of motion, the symbolic set substitution, with various substitution. These are the common substitution for the terms. We obtain finally a ratio that is the one in the box. Just remember the function. And that formula is the result I came to in the first video about this topic. But as it is unnatural to consider a negative displacement, that above all is visually contrary-synced to the cosine that describes the motion, we now write the equation of motion for the second thrust, which is another in regime 1, considering the usual symbolic set substitution. But before, what I mean to visually contrary-synced to the cosine that describes the motion, I mean for you that are watching, if we describe the equation of motion for the third thrust, the mass is on the left and begins to oscillate from the negative displacement. So starts from here and goes like this, and goes like this. So starts from here and goes like this. The cosine somehow, if you have it in your mind, is a rotating vector that goes like this counterclockwise. So if you so that you have an object, the mass, that moves from the left to the right, while the cosine goes from the right to the left. So if we now write the equation of motion for the second thrust that starts from the right and goes to the left, the cosine that describes the equation of motion goes together with the mass. I mean, the mass is here and goes towards the left. The cosine starts from 0, and while it rotates, also goes from right to left, so that somehow this is the situation. And this eases up a lot the comprehension of the phenomenon. So the situation is this one in the schematization. This is the equation of motion that becomes this one, as I already wrote somewhere in a previous slide or video about this topic. And we are using the usual symbolic set substitution. Hence, going with the substitutions, we have the equation of motion. We divide by the mass. Then with the usual substitution, we obtain this equation. And finally, this relationship, this formula, there is the same result as the previous case for the third thrust. To sum up the visual explanation, just to have clear ideas, here are the three instants considered altogether. So on the left it's the first thrust, on the second, in the center there's the second thrust, and on the right there's the third thrust, and the second and the third and the fourth and the fifth and so on are all thrusts in regime motion. The first thrust is a singularity one and happens in resonance. So if you see at once again the displacement, the first is starts from the balance point, from displacement equal to 0. The second is for maximum positive displacement. The third, or all the odd ones, and all the odd ones start from negative maximum displacement. All the even ones start from the maximum positive displacement. And you can see the difference between the first one, that is the only one that once again have the force, the driving force and the displacement, both pointing to the same direction, and all the other ones have always driving direction of driving force and displacement always opposite one to each other till resonance. Hope this clarifies and helps the comprehension of my position about the current forced oscillation theory. As a consequence of the signs shift, a few things happen, and you can see the following table taken from the previous original video on the topic, that maybe I will link somewhere or in the description or in maybe in the upper right corner of the video. This is the situation before changing the equation of motion, and that's the effect of that minus negative sign in the equation of motion. I repeat, I linked the original video, the first video on this topic, in the description or maybe in the upper right corner. And we are done. So feel free to comment or contact me, and because we are on YouTube, please subscribe and click on the notification bell to receive updates on this and other ideas that I come up with. And consider to give a thumb up too, and share link or talk of this video with anyone that could be interested in this topic. So until next time, stay strong.